This is Geometry Semester 2. It's the third unit, Solids. It's the fourth lesson, Volume of Triangular Prisms and Slant Triangular Prisms Practice on CreatorMath.com under the Geometry tab. Copy the following problems 1 through 4 into your comp book. There's only 4 problems here. 1 through 4 into your composition book on the correct pages according to the table of contents with the notes for these pages. Please don't forget the notes. It explains the different formulas we're going to use as a part of calculating volume for these triangular prisms from CreatorMath.com under the Geometry tab. This first one says, what is the volume of the following solid with length A? And this one is hard to see. It's a little bit better if you bring it up in a PDF than my printed version here. My printer doesn't seem to do it justice. This is a lighter H. So they're telling us H is 5 inches. Base, which is the base of the triangle back here, is 4 inches. A is 7 inches. So the volume of a triangular prism is the area of the triangle on the end. And this is in the notes. When you write this in, you'll have a better explanation of this, times the perpendicular height. I'm going to do perpendicular height. So 1/2 base times height is the area of a triangle, 1/2. The base of this triangle is 4, and just to draw this out a little, it's like this, 4, and it's this height here of 7. So 4 inches times 7 inches times perpendicular height, 5 inches. So notice we have inch times inch times inch, which is great. That's going to give us inches cubed, which is good because it's a volume. And then, looks like we have, let's do 4 divided by 2 is 2. 2 times 7 is 14. And 14 times 5 is 50, plus 20 is 70. So 70 inches cubed. This repeats, shockingly similar, as long as we use perpendicular height. It doesn't matter that we have a slanted triangular prism here, also called oblique, O-B-L-I-Q-U-E. I wanted to say oblique when I was younger, and I learned it was oblique. It just means slanted, but notice the top is parallel. The two bases remain parallel to each other. Almost the two had started parallel, and then were like pulled over with the shape slanting, but the base on the top and the base on the bottom staying parallel. You've got a triangle here, so our volume equals area of the triangle times the perpendicular height. I'm going to put perp height, H-E-I-G-H-T, there we go. Remember, perpendicular height is 90 degrees to the ground or to the base, right? It's when the same thing used called altitude for an airplane. You don't measure the altitude at a slanted angle. You measure it perpendicular to the ground right here. So volume equals area of a triangle, which is 1/2 base times height, times perp height, perpendicular height. Volume equals 1/2 the base of this triangle. So let's see here. We have a base of the triangle of 4 inches. That's from here to here. So we've got a 4 inches. Include the units. I have a height of the triangle. So it's interesting. I've got a height here and a height of the shape. So imagine a triangle like this, right? There's a height to the triangle and a base here and here. That's going to give us the area here of the triangle. But then there's this overall height of the whole shape, which is the perpendicular height. That's why they're separated perpendicular height of the shape and height of the triangle. The height of the triangle in this case is A. They show us over here fading away. A is 7 again, so this is 7 inches. The base is 4 inches. And perpendicular height is 5. And notice they've given us the same dimensions over and over and over, illustrating the fact that if you're using the perpendicular height, even if the shape is oblique, the volume comes out the same as long as the perpendicular height was the same as a non-oblique shape. All right, fair enough. So 7 inches times perpendicular height of 5 inches. Inch times inch times inch gives us inch cubed. Good. 7 times 5 is 35, divided by 2 would be 17.5. That seems too hard. Let's go 4 times 7 is 28, divided by 2 is 14, times 5 is 50, plus 20 is 70. Same one. I'm just walking you through the calculation in my brain. I know it's 70 because it seems like they're doing this over and over. Did they give us a new set of dimensions here or not? We've got an h over here. We've got an a, which is the height of the triangle. Pull this triangle out. This is the height of the triangle. And it looks like we have a base up here. So the height of the triangle is 6 centimeters. So this distance here, which is A, is 6 centimeters. The base of the triangle is 5 centimeters. Finally, they give us different dimensions. The height of the shape is 10 centimeters. So volume of a triangular prism is the area of the triangle at the end, area of triangle, times the perpendicular height. H-E-I-G-H-T. There we go. Come on. V equals 1/2 base times height of the triangle times the perpendicular height, PH. V equals 1/2. The base in this case is 5 centimeters. I'm including the units. Please do the same when you calculate it. 6 centimeters here. And you'll see why 10 centimeters. By including the units, it gives us an illustration of why this thing is base times height, why it's the area of the triangle times the height, because now we get centimeters times centimeters times centimeters, or centimeters cubed. Perfect, because we need a volume. If there weren't 3 of them here, multiplying to cubed, we'd have a problem. We'd have to go back and look. 5 times 6 is 30, divided by 2 is 15, times 10 looks like 150 centimeters cubed. So far, so good. Nothing too complicated other than maybe just illustrating that the perpendicular height of the oblique shape is the same, because I bet they might use, let's see here. Here's our height of the triangle, A again. Here's our perpendicular height of the shape. They're giving us the height of the triangle is 6 meters. Oh, they're really shaking it up on us. So here's the triangle, right? This A represents the height of the triangle, 6 meters. The base of the triangle is 7 meters. So 7 meters, and here's this base. And the height of the shape, perpendicular height, is 10 meters. So volume equals area of the triangle of the ends, or bases of this thing, times the perpendicular height of the thing, or altitude. Area of a triangle is 1/2 base times height, and that's going to be the base and height of that actual triangle, times the perpendicular height, PH, of the entire shape. Volume equals 1/2 base of the triangle is 7 meters. Include the units. The height of the triangle is 6 meters. The shape height is 10 meters. Meters times meters times meters is meters cubed. We're happy about that. 7 times 6 is 42. Divided by 2 is 21. Times 10 is 210. 42 divided by 2. I get 210 here. It's going to be this one because I'm going to fix it and make that 210 for you guys. Okay? I don't like 220 there. Unless I'm doing it wrong, which I don't think I am for the moment. So these are volumes, and they're illustrating to us a triangular prism and finding the volume, and especially illustrating to us the idea that a slanted or oblique triangular prism still has the same volume formula as long as we utilize the perpendicular height of the shape, and you should be using that for all your volume calculations of all the different shapes. That is very consistent that you need a perpendicular height. This is the geometry semester 2. The 3rd unit, the 4th lesson, volume of triangular prisms and slant triangular prisms, practice on creatormath.com under the geometry tab.